Capacitor explained. In this video I'm going to explain what is the capacitor and how does it work in the circuit and how do we connect the capacitor in the electronic circuit. The capacitor is a component that has the ability or capacity to store energy in the form of an electrical charge, producing a static voltage across its pins, much like a small rechargeable battery. So that means that the capacitor works like a small rechargeable battery. It has a capacity or the ability to store energy, electrical energy of course, okay, and then release this energy or this electricity if there is load on its pins, okay. The construction of a capacitor. A capacitor consists of two or more parallel conductive or metal plates which are not connected or touching each other but are electrically separated either by air or by some form of a good insulating material such as waxed paper, mica, or liquid gel as used in electrolytic capacitor. This insulator layer called dielectric, okay. So what does this mean? This means that the capacitor consists of two conductive metal plates that are parallel or put together in parallel way, okay, with and separated from each other by some insulating material such as air, some form of wax paper, liquid gel in the electrolytic capacitor, okay. So this, as in this image, explains that we have two plates, okay, two plates together, okay, and then between them there is the dielectric material or the insulating material or the insulator layer, okay, and then they fold these layers together and making this type or this form or this shape that we know as the capacitor, okay. So let's see what's next. Okay, the changes that the capacitor do to an AC voltage or current. By the way, the capacitor doesn't work on the DC current, because if we put a capacitor into a DC current, that will block the current or the DC current, the direct current. Why? Because there is a layer, insulating layer. This insulating layer will prevent the DC current from passing through the component, okay. So what so that means that the capacitor must be connected to an AC current, okay. So what is the changes that the capacitor do to an AC voltage or AC current, okay. As in this image we have that the capacitor, this is a type of an AC current, okay. After we put a diode, we are going to explain what is the diode next time, and after we put the diode, it will give us this wave, okay, this waves. These waves, we need to make it more similar to an DC current. The DC current, we know that the DC current is a line, okay, not this sort of waves, okay. So the capacitor will make it more similar to the DC current, okay. So we have this AC waves. So when the capacitor charges, the capacitor will charge right here, and then it will discharge its capacity, and then it will recharge again its and then it will recharge and then discharge this electrical energy, and this and then it will recharge and discharge and etc, okay. So that means that the capacitor will recharge and discharge its capacity, and then it will give us a sort of or a similar wave to the DC current, okay. The capacity of a capacitor measured in Farad stands F stands for Farad, but usually it's written on the capacitor in microfarad. Okay, so and the micro is a unit to describes the small values because it equal to it equal to 10 power minus 6, which means that if we have, for example, 4 microfarad capacitor, it is equal to 0.00006 farad. So this is a very small farad because we are doing an electronic circuits, and in the electronic circuits we use a very small values of the capacitors. So we are going to use a microfarad to make it more short than we it's not good to say 0.00006 or 00 or 0.00. Sorry, this is 0.00004, not 6, because this is a 4 microfarad. Okay, so that means that this is a very small value, so we use the micro to make it easy to say it. Okay, so let's see the next. It's circuit symbols. Okay, we have a lot types of capacitor. Okay, there is a 4 famous types of capacitor. The first one is a capacitor, normal capacitor. The normal capacitor doesn't have any polarity, which means that if we connect it in the circuit, if we put any pin in any place, it will be the same. But we have another capacitor. The capacitor in this capacitor is polarized, which means that it has a pin that must be connected to positive terminal and the other pin must be connected to the negative terminal. The third type is the variable capacitor. The variable capacitor, we can change its value by using a screwdriver and then rotate the screwdriver, and then we are going to change the capacity of this capacitor. We have also a trimmer capacitor. A trimmer capacitor is also a variable capacitor, but we change its polarity not using a screwdriver, but some sort of a screwdriver, but not the usual screwdriver that we are using. Okay. If we are going to use the capacitor to convert AC current to DC current, make sure that I have explained how we convert from AC to DC, from the wave that we have said to the other wave, the wave that is similar to the DC current. Okay, so if we are going to use the capacitor to convert AC current to DC current, we must connect it in parallel with the load. Okay, as in this image we have that we connect the capacitor. This is a wrong way to connect the capacitor. We don't connect the capacitor in series. Why? Because there is a insulator layer or insulating layer between these two plates, so that will block the flow of the current. So we must connect it in parallel with the load. Okay. So that's it in this lecture. See you in the next lecture.